Hey folks, thank you for joining us at the WAIUG. My name is Mike Walker of XDB Systems, and I'm going to be doing a presentation on Informix Auditing. So this is, I started this presentation, or gave this presentation a few years ago, and in the last few months I've implemented auditing in a couple of places, so I think it shows that there's still a need uh, for auditing using the Informix's built-in capabilities. And so I decided to refresh this presentation and include some of the stuff that's recently been introduced, specifically auditing to syslog. Um, so I'm just going to dive in here. So let's start off with describing what Informix auditing actually is and what it does. So specifically, you specify what sort of events that you're interested in capturing. And when those events occur, they get written to a simple text file, or now they can also be written to the syslog. You can use this to specify all these different events. There's a big long list of them. So you can start capturing who connected to your database, whether changes were made to any data, changes were made to any schemas, somebody started changing grants, for example. So you can log all that into this file. Now, the nice thing about Informix auditing is that it's really easy to set up, um, and you can enable it without any additional cost. You've already got it if you've got Informix. The main reason that we've been setting up auditing is normally to try and satisfy an auditor requirement. Somebody's been asked, do you do auditing? And they want to be able to reply, yes, we do auditing. And this is an easy way to satisfy that. It may not check all the boxes, but it's an easy way to be able to answer that question that, yes, we do auditing. Now, I think it's important to also explain what the Informix auditing is not. So there are some limitations. Specifically, it does not capture any SQL that's run. And often we're asked, so I saw that user so-and-so logged into the database, but I don't know what he ran. Like, did he do an alter? Did he changed some data? What data did he change? I want to be able to see the SQL statement. You can't get that with Informix auditing. All you can get is like, okay, user, somebody connected at this time and ran an update statement or something. So it is important to know that you can't get the SQL and also the details of what was performed by these users. Uh, it's kind of limited in what's captured. So even though it's easy to set up the auditing, you still don't have things like automatic alerts. You do need to um, do some things like write scripts to archive the data, or maybe to parse the data, the auditing data, and send emails or send out alerts. Um, so that's something that you still need to do, even though in addition to just enabling it. Ideally, you set up role separation. We'll cover that later, but really it's just setting up different users with different roles so that you limit who can change some of the auditing information that's logged or modify the files, that kind of thing. So I'm just going to show you here what the audit file looks like. So here's an example of some information that was written. And then later on, we'll drill into this to see what it's actually telling us. But you can see it's just plain text here. And it even looks like this if you're auditing to syslog. But here we're just looking at the file that's written. And there's these codes that say what the event is that happened and when. So starting auditing, it's very simple. We either modify a configuration file in the same way you might modify the onConfig. There's auditing has its own configuration file that you can just change, and then you restart Informix to enable auditing. or you can just do it without taking the database down and use the onaudit command. The onaudit command is one of two commands that you'll use a lot with the auditing. So here's an example of the default auditing configuration file. It is under Informix in a subdirectory AAODIR, and the file is called ADTCFG. So this is your basic initial auditing configuration file, and you go through this and you make the changes that you want. Restart Informix and auditing's enabled. Uh, all of these items you can also change online with that onaudit command. There's one option for each of these parameters in here. Now, if you used auditing prior to 1410 XC6, this file was a lot simpler. It was a lot shorter. A lot of these options here have been added in 1410 XC6 for auditing to syslog. So there's a few things that you want to review before you start Informix, just before you start auditing. Some very simple items here. The first, and this is how you enable auditing prior to 1410 XE6, you change the ADT mode, and 0, the default is auditing is disabled. If you just want to start auditing, you set it to 1. But then you've got some additional options here, whether you want to add additional auditing for the DBA, like the Informix user, or the database security officer, which is another role that is used by auditing if you're doing role separation. Now, after 1410 XE6, we've got these additional options, and these kind of replace the ADT mode. And here we just have ADT Classic enabled. We set that if we just want to do the basic auditing to a file, not syslog, but just to the text file. So we can enable that. And instead of the overloaded option for ADT mode, we now have separate options for the DBSSO and DBSA, whether we want to audit or add additional auditing for those roles. ADT path is where we want our text files with our auditing information to be written. And we can also set a maximum size of each file. So we don't just have one file that's just ginormous, but we can say, let's make it about, a gig or whatever before it wraps to a new file. So if we want to enable auditing and change these values with the onaudit command, there's some examples of how we might do it. So the onaudit-p is where we can specify where we want our files to go, our ADT path. Now that directory must exist, otherwise we'll start getting errors. And you also want to make sure there's plenty of room there. Depending on what events you're auditing, that can get pretty big. So you want to make sure that there's enough space so you can continue to write out your audited events. The maximum size of the audit files is changed by ADT size, which you can do with the onaudit command onaudit-s, and that value is in bytes. Now, turning auditing on, now if you're before 1410 XE6, you can just do onaudit-l1. That will simply turn on auditing right there. Now, after XE6 or XE6 and after, we have these additional options where we can do onaudit-L on, and that will audit to a file, or the new option onaudit-E, and that will, if we enable that, it will start auditing to syslog. Now, you can have both auditing to a file on and auditing to syslog. Now, instead of those other options before 1410 XE6, where you can enable additional auditing just by changing the value for -L, now we can specify each one separately by changing changing the value with onaudit-S or capital A. We can review the auditing configuration with onaudit-C, and we can see all the values that we've set. Here's an example file. And we see how we can have auditing enabled, and separately we specify whether we want extra auditing for the security officer and the database admin. As soon as we're starting auditing, we'll see a new virtual processor spin up of type ADT. One thing to note is that if you are using the onaudit command to modify the settings and the configuration, it will create a clone of the ADT CFG file with your new settings, and it will just put the server num on the end. If you choose just to edit the file, then you can just change the ADT CFG file. Now, something important here, you can turn on auditing, yet you will not see anything captured in the audit files. So by default, nothing is audited. Instead, you then choose what events you are interested in auditing. And there is a big long list of those, and they're all 4-character codes. Here's a few examples: OPDB to open the database, CRTB, someone creates a table, we want that to be recorded, or another one, GRDB, grant database access. So part of setting up auditing is to decide what events you want to capture, what users you want to capture them for, and then add those events to the auditing as these are the events that I want to track. And we do that by using audit masks. Now, we can set up masks for a particular user, and different users can have different masks, mask being a set of those events that we're trying to capture. Um, but there are some built-in masks. There's underscore default, underscore require, and underscore exclude. Now, these are empty at the beginning, but they are applied in a certain order. So if you have a mask for a named user, that one will be applied first. If there is no mask for that user, then the audit events, those 4-character codes, will be pulled from a default mask if there is one. And if you've got a require audit mask, that is like the minimum set of things you want to record, and each user will inherit that require uh, required codes. But you can say, hey, except for this user, this user I don't want to record like every time they open a table or something. So it is a good idea to at least have a default or a require. That way, if there's new users to start connecting to your database, you don't need to go ahead and set up a mask for that user. They'll automatically inherit what's in the default or the require. So to add an audit mask, we use our onaudit command again, this time with -A for add. So here in this example, I'm creating a couple of basic audit events of open a database and close a database uh, for the mask underscore require. So everybody, no matter who they are, will automatically now if they open a database or close a database, they'll have an entry recorded in our either syslog or our auditing file. We can modify, or we can add a separate mask for a named user. Here we're adding a mask for Jack, because for Jack, we want to know if he creates a table or drops a table. And those are the 2 event codes listed here. To list the events or list the things we're capturing for these audit masks, we use onaudit-o, and that will just list each mask and then the events that we're tracking. In this case, so we see Jack. We're monitoring if Jack creates a table or drops a table. But also the events closed database and open database will be captured because they are in the underscore require mask. We can modify mask with the -m option. So here we're modifying the mask for user Jack, and we're adding the insert row event, and we're dropping or removing the drop table event. A nice feature is that we can clone or copy a mask to another user. So here I'm creating a new audit mask for user Jill based on Jack's uh, audit mask. And at the same time, we're also adding a couple of extra events. And then we look at the audit mask. We now see Jill added. Jill now has Jack's audit events plus a couple of others, and we also know that we'll be auditing what's in underscore require. Now, using that same feature of being able to copy an audit mask for another user means that we can create a couple of template masks so that when we add a new user to the database, we can say, okay, and like in this example, they're a read-only user or a read-write user, and we can just say, okay, for this new user, let's just copy over one of these, like in this case, the read-write uh, set of audit masks. We can, of course, delete an existing audit mask with onaudit-d. Now, I said there was a ton of these different events that we can capture, and you don't want to start plugging those in for every user. So you can just create a file with all those codes in, and then just go ahead and, in this case, I'm adding them to the require. Yeah, the require mask. So we'll just load that in, and now all users will be tracking these events for all users just because it's in require. And you see all these codes here, some of them pretty obscure. Now, it's tempting just to say, well, I'm going to audit every single event for every single user. Sounds like a good idea until you start creating these massive files with all of these events that you're capturing. And it's just going to be not practical. But so you've got to give a lot of thought to what events you're actually interested in capturing. Now, when you think that this is a lot of these events are written to a flat file, you can imagine if you're capturing every single thing, insert rows, delete rows, whatever, it's going to get a little big, a little quickly when you write to these files, and there's going to be a performance impact. Any performance hit from adding auditing, most of it will likely be writing to these files because now we're just writing to an OS file. And it could be, if you've got a lot of users and you're capturing a lot of events, that's going to be a lot of writes. A couple of extra things here about the audit file. The name of that audit file, it'll be saved, the file will be saved in the directory we use for ADT path, but the file itself will be named Informix server and then a number starting at 0. And that file, if it grows beyond the maximum size that we specified in ADT size, then it will create .1 or .2. It's a sequential number. They'll just keep increasing when that file fills. But if you also restart Informix, then it will automatically switch to a new file. Now let's look at the events that are in detail that are logged in our file. So here I've got an example of a user Jack. We're tracking the open database and closed database events. So here's the string that is written to the file. And as I've highlighted here, here's the event that triggered this entry in the file. So we've got an open database and a closed database. But what's important here is because we've only specified these in our audit mask, we have no idea what the user did while they were connected to the database, because we're not tracking any other events. So that it's easy for there to be holes in your auditing because we're never capturing everything that happened. So we need to be sure we've given a lot of thought to what it is we want to track. Now, digging in a little bit further here, looking at this line, we see it always starts the same way: ONLN, followed by a date timestamp, followed by the host name, the process ID, the DB server name, and the user. So all entries will follow this same format. Where it differs is the event that has been triggered. So that varies depending on which event it was. So for the open database, we have an error code. Here we know that the database open was successful. Here's the event code. Here's the database name. And then I can't remember what that one is. So you'll see that all of these events, or the details on the event, are separated by a colon, whereas the initial fields are separated with a pipe. The point here is that the values here in this last field, they vary depending on what it is or what the event is. So looking in here, looking at that open database, the last item was whether the database was open in exclusive mode or not, and followed by whether a password was used. Now, if we look at a corresponding entry, the create table, now we've got this, the elements at the top are the same. We've got our different event code, create table, but now we have these fields. We've got the database name, a table ID, table name, table name, the table owner, and a code representing whether the table is fragmented, followed by a list of DB spaces. Here, we're not using a fragmented table, so we don't have a list of DB spaces. But by having all of these different fields, depending on what the event was, it does make it a little complicated to report on, because you got to do essentially a case statement to say, all right, this was a create table. That means I want to get my table name from this position, and so on. Looking at an example here, we'll just go through this. This could be something where you look back at the audit file and you're like, okay, what happened today? So we can see here that user Jack tried to open a database called NoDB, which doesn't exist. So 329 is the error code that gets reported, and logged in the audit file. Here we can see that the user Jack now tried to create a table called myTab in the root DB space. Here's a case where we've got 3 rows inserted. Now, what we see in our audit file here is the event code, the database name and stuff, and a tab ID. We don't see what the table is. We just have the table name is, we just have a tab ID. And we see the row IDs that were created. So that's nice and everything, but if that table later goes away, we don't know what the original table was. Even if the table's around, we have to look it up by tab ID. Okay. We also don't see the contents of that row. And if we look at the following update here, so we know the user's updating that row, and we've got the tab ID, and these are the row IDs. So, okay, so Jack updated the 162 table, which we know from earlier is my tab, but we don't know the details of the change. So this, I think, is a limit of the auditing, right? We know kind of what happened, but at a high level, we don't know the details. of what was changed. In order to do that, we got to be capturing the SQL, or we've got to be using triggers on the data to record the before and after images of that row to really find out what the change made was. Okay, and then we can see that this user then deleted the rows. So based on this, we know kind of what the user did, but not enough detail. Like what if that user was updating some, banking table to change their banking information to their own bank or something? I don't know. We don't see those kind of details. So this auditing should be used with other mechanisms to secure some of that data in those other tables so you can track it better. So just saying here that that there is a level here, level of detail that is missing just by using Informix auditing.
Hey, Mike, can you go
Yeah,
back a second? There's a
sure
question
can.
that
Oh,
is 104.9096 a partition number?
I think, yeah, that's the part num of the
Yeah.
table. Yeah. And all of these items here are described. Let me just bring up, I added this here. So if you can see this, okay, I'll zoom in a bit. This is the documentation, and it lists all of these codes down the left here, alter index, la da da. If we look, I think what we were looking for, update row, was it? Oh, update row, was it? Yeah, here, insert row is what we're looking at. So if we look at this, we see the code, the nice name of it, insert row, and in this third column, we see the variable information that is captured for that event. So in this case, it's listing the database name, the table ID, and the partition number of the fragment, right? Followed by the row ID. Okay. All right. Okay, moving on to some of the new features that we see now where we can audit to syslog. So here we set a value in the configuration file ADT syslog enabled. Once that's turned on, instead of or in addition to writing to the file, that same information will also be recorded in the syslog file. So you'll see the format is pretty much the same. We've got our date, time, host name. Uh, I've got my Informix here. It's another item we can set in the configuration file, ADT syslog identifier. By default, it's the same as Informix server, but we can change it, override it by setting this value. But then you'll see the stuff highlighted here in red is exactly the same as we see written to the file. It's a pipe delimited set of values beginning ONLN, date, time, stamp, host name, process ID, that kind of thing. So this is a start session, open database. So same kind of thing, but now it's written to syslog. So if we look at the configuration file, we've got our syslog enabled syslog identifier that I've just mentioned, but we've also got these other values. So we've got syslog options, syslog facility, and syslog priority. Now, those of you who are more familiar with syslog and syslog-D, these may mean something or may mean more to you. So often you may want to just leave these at the default, but where they come, well, where they're useful is if we can set these to other values, it makes it easier to pull from syslog. Because we can use these as like identifiers for our auditing records. Now we can't have logic in there to say, okay, If somebody accessed a database, then that's, a low priority kind of thing. And if somebody drops a table or adds a grant, that's a high priority thing. We can't do that because all of this applies to everything that gets written to syslog. So here's an example where I've set the syslog facility to log local 7 and priority to log alert. Both of these, you can't just set them to anything. It's described pretty well in the configuration file of these are your allowed values. So I've just chosen a couple here. Now I can use our journal CTL command just to keep an eye on our syslog, and we can use dash dash priority or dash dash facility to now filter the entries in syslog to pull out just what we're interested in. Like, hey, out of all the other noise in our syslog, these are the values here for Informix auditing. Okay, so now we've spoken about you've got to be careful about the events that you capture so things just don't go crazy. You can imagine if you've got a billion row table and you're doing an update to populate some new field or something. I mean, alone that can be a problem. But imagine if you're also recording every one of those updates in your text file. That can be a bit much. Uh, what you may have in your database is, you've got, a few hundred, few thousand tables, but there's only a few that you're really interested in that extra level of detail. I want to know if somebody changes the banking information, or if somebody adds a new vendor, things like that. You may want to say those set of tables, I want to record if somebody has made changes to data within those limited set of tables. Everything else, my transactional tables, I really don't care about. But these ones I keep a close eye on. Now we can do that by setting row level auditing. If we enable this in the config, um, we can now say this set of tables, I want to capture auditing information. And specifically, that's delete row, insert row, read a row, or update a row. Yes, read a row. Can you imagine you just do a big sequential scan on a large table and we record an entry for every record that was read? That's just going to fill up our syslog and fill up our text files very, very quickly and have a performance hit. Yet there's some tables like, okay, there's a limited set of users that should be reading from this table. So that's a good example. Now, all the other events, like whether you're adding grants or altering the table, those will still apply to all tables. But the way we do this, once we set our onaudit-R to enable our row level auditing, we set it to 1 or 2. We then need to say, okay, these are the tables I want to capture that additional information on. So you can either create the table and you add the keywords with audit, or if it's an existing table, you can add auditing to the table. So this just says for tab 2, I want to make sure that I capture the insert row and update row, read row, all of that kind of stuff. Let's talking about the audit files themselves. So these are placed in the directory we specify with ADT path. They're named the server name followed by a number. And when they reach that maximum size, we'll switch to a new file. But we can also force a switch to a new file with onaudit-n. That might be something you want to do every day, like at midnight, you run onaudit-n to switch to a new file. And so you start off with an empty file for the new day. You can find the current audit file with that little number on the end by looking in this file, adtlog.servernum. and it will tell you the current file that is being written to for auditing. So I said it's easy to create auditing, but you do need to come up with a strategy of what you're going to do with all these files. Um, an example might be I want to retain 6 months of files or less, and when they get older than that, I'm going to just move them somewhere else into this big archive file system, zip them up, and then after a year, I'll just purge them. You need to decide that. Um, before those files get too big. Uh, Otherwise, if you're just planning to turn on auditing and leave it indefinitely, then you're just going to fill your file system. Now, the second command, I've already gone on a lot about on audit. The second command with auditing is on show audit. So I said how these auditing events get written to a text file. So it's easy just to, tail it, grep it, that kind of thing. So the on-show audit command, though, is a way to view those files, and you can search for a particular user, that kind of thing, and all of this. Plus, it doesn't, if you don't use any options on it, it'll look through all the audit files that are in your audit directory. So we can specify a particular file name we want to display, files for a particular server number, or even a user and a server name. So it's really just like ways to grep that data. You can use the -L option. That will change the format of the audit strings. So I said how everything is pipe delimited, apart from those last few fields that are colon delimited. If you use -L, it'll put in a pipe in that last field. That's going to make it a little bit easier to parse or to load into a table. So here's some examples. Here I'm using onshowaudit for events by user Jack. And we see how this last field, the event specific fields are separated by a colon. If we use -L, then those same values have pipe delimiters. So it's easier to parse, easier to load. There is an option, with 1410 FC6 and after, we've now got a new option -D, which limits the double spacing on show audit, which used to be kind of annoying. There used to be blank lines between every entry. -D will suppress that. There's also a -Q to get rid of the header line and some other stuff. So I'm going to jump right into a demo here, which I'm going to show you how easy it is to set up Informix Auditing. So I'm just going to go ahead and I've got my database running without auditing. I'm just going to shut it down because although I like to change these values from the command line, in this example, I'm going to change quite a few things. So it's just easier and quicker just to modify the configuration file. Now that file is in Informix AAO-dir. We look to see what's in here. We've got our ADTC CFG standard file, and we've got our basic ADT CFG. So here's our configuration file that we are going to edit. And we don't change the STD one just because we want to leave our defaults there. So I'm going to change our path here to inf-audit, which is a directory I've already created. 50,000 bytes is too small for a file, so I'm going to make that a bit bigger. I haven't gone into all of these options. They are quite well documented. And my earlier presentation, I think, describes them all in more detail. I'm gonna enable our classic auditing, which is essentially our writing to a file. And I also want to track our DBA actions. So even when we haven't created any masks, by doing this, we will be turning on auditing for things that, in this case, the Informix user does. So we'll take a look at what happens there. Now, I also want to, whoops, audit to syslog here. And I'm gonna say my inf, my FMX, let's do that. So that's a little identifier that will be placed in the syslog entries. Now, these other options here, these last two are ways that we can use to use journalctl to parse or pull out items from syslog of interest that are to do with auditing. So just for fun, I'm going to change this to local 6, which is, you can just look at the documentation in the comments and that'll tell you the valid values. And just going to change this to alert. You may have other values that work for you, but I just chose some random ones that we can use for filtering. Okay, I'm going to save off this file and start up Informix. Okay, got the log file. Okay, we're up and running. Let's look at our virtual processes. And we now have this ADT one running. So that's our auditing virtual processor. Now let's go over to our one here. So InfAudit was the directory I had already created. And let's see what we've got in it. Okay, so we have a file which is named Informix server.0. It's our first file here. And let's just see what's in this guy. Okay, so remember I said we are not, or no events are audited by default. That's correct, except if we have enabled additional auditing for the DBSA user, the Informix DBA user, or the security officer, then those items get logged automatically, okay, even without a mask. So this is showing me the commands I used to start up Informix. So we've got our on init, we've got an onstat-m, and onstat-glo. So those are logged, even though we have no audit masks. And we can see our audit masks with the -o-y. If I don't use the -y, it just says, hey, you sure you want to do this? Yes. We got nothing, right? Because we haven't set up any masks. So that will mean if a user goes in and starts messing with our data, nothing will be recorded, assuming it's not our DBA user. So what I'm going to do here, I am going to tail this. Right? And this is interesting. Because I've been running on audit as the Informix user, we see items logged for that user, for Informix there. We've got start a session, open database sysmaster, we access a table, we read a row. So we are getting information logged here, but not the details. But it's interesting that by running commands, you'll kind of get an idea of what happens behind the scenes. Hey, an entry was made in sysmaster and so on. So if I go in this window, nope. Oops. To switch to a user ID here. So I am going to So as this user Jack here, I'm going to run some SQL. Okay, so this user went in, tried to open a database, tried to create a table, or successfully create a table, added some data, and so on. If I look at our audit file now, I'm not seeing anything. I'm not even seeing that user Jack accessed a database because we haven't created events for them. So what we're going to do now, as we're going to switch back to Informix user, we're going to add a couple of audit events. And we're going to require, now, so this is going to be for all users, we're going to require the logging of anybody who opens a database or closes a database. And you can see this window changed here to show some additional items. While I'm here, let's take a look at syslog. And you can see right here, we've got all of these entries. Not only are they logged in the our auditing file, they're also logged right here in syslog. And what I can do in this window, I can run and so journal CTL-F will continue to list out new entries in syslog. And I could just do that and see everything. Or what I would like to do is just use those filters. So we can use facility, local 6. If you remember, the items I put in the configuration file were like log local 6. And also, right, spell it right. So this will sit here, and any new entries in the syslog will be written out here. So now I added the require. Let's take a look at our audit masks that we've got so far. We've just got this require here for closed database and open database. I'm going to create one for the specific user because we want to keep an eye on Jack. We think he's up to no good. So we're going to add a mask just for user Jack. And here I think we're going to see if Jack creates any tables, drops any tables, inserts a row, updates a row, or deletes a row. Check our audit mask to make sure everything went in okay. And there we go. So now let's go back in as user Jack, run that same SQL. You saw this, zoom up the screen here. Now we see all these entries for Jack. We're creating a table, inserting a row, updating, deleting, and finally closing the database. Now we can use, while we're looking at this, here we're just tailing the text file. But we can use our other command here, onshowaudit. And we can see all the entries here. Remember what I said about that double spacing? We can now use -D to list it a little neater without those blank lines. And we can also filter by various things. Here I'm going to filter by user Jack. So now we can just see what Jack did. We can hide that status message there, or the header there. And you see how these items at the end here have got colon separators, which makes it difficult to load without modifying it. We just add -L on the end, and it changes them to pipes. But now we've got to get rid of our -D. So now we're in a format here. If we wanted, we could just go ahead and load this into a table. All right, that's the end of the demonstration. I do have a few more slides though. So let's just wrap things up. Um, so the last thing to discuss is role separation. So if you want to use auditing properly, you want to make sure that the files that are written are secure. Um, like how many people have your Informix password or use your Informix ID, right? If there's a lot of them, then you kind of undermined a lot of what you're trying to accomplish with auditing, because people can go in and they can change the audit masks, so they can like remove the their user ID possibly, and they can modify the files, they can turn off auditing, they can mess around with a lot of that auditing stuff. So using role separation allows you to limit what each person can do, and that your Informix ID is only used for your proper admin access and nothing to do with auditing. Now, the roles are the Audit Analysis Officer, AAO, and that person can configure the auditing, review the information, and change your audit files or manage them. Your System Security Officer is the only one who can modify the audit masks. And then, of course, your DBSA or your DBA can carry on and do the normal database administration tasks. If you're going to use role separation, you need to create additional Unix groups, not user IDs so much as groups. And then for each of the users you want in each of those groups for AAO, DBSO, and DBSA, you add them to the group in Unix. You can set up role separation when you first initialize Informix or when you install it. And if you choose the custom install, not the normal typical install, you'll be prompted for the names of the groups for the DBSSO and so on. Oh, that should be AAO. If you do it after installation, uh, these directories that we've already visited here during this presentation, you need to change the group owner of each of these to be your specific groups. And you change the permissions on init, and make sure that your onConfig and SQL host is still owned by your DBSA group. So once you've done that, you've enabled your role separation. And if once you've got that enabled, you try doing things under the wrong group, then Informix will prompt you and say, nope, you can't, this is trying to turn off auditing. You can't turn off auditing if you're the Informix user. You must be the AAO or DBSSO. And other restrictions with on-show audit, other options on audit, and so on. They must only be run now by the specific users. Okay, about to wrap up, but there's a few things that you need to ask yourself before you implement auditing. So I try to list a few things here, like where are you going to put these files, and do you have enough space for it? What is your plan for retention? What are you going to do with all that data? I've mentioned before how you need to think very carefully about what event it is you want to capture. Like, really, do you want to capture everything for all tables? Or do we want to use the row level auditing and try and limit how much we're capturing on specific tables? So I've already said how the data is a little bit limited with that's captured with the auditing. And if you were looking for SQL to be audited, you need to keep looking, because auditing here, the built-in Informix auditing will not save that. Do you want to assign different people to different roles? Like, this person is your audit administrator, this person's your security officer, and so on. So that format is also kind of difficult. So what do you really want to do with all this data you're capturing? Yeah, you can say, yeah, we're doing auditing, but is it of any use? If you're just capturing those files, why are you capturing those files? What do you plan to do with them? Do you plan to look at things proactively. So like keep looking at stuff, go, oh, this user tried to do this, or you're only going to go back to those files if you hear, oh, the table's disappeared. So then you can go back to those audit files and see who may have dropped it or altered a table. So the overall question is, given what Informix does and what it doesn't do, does it solve the problem you're trying to solve? Now, so yes, there are some limitations with the auditing, but the good thing about it is that it's very easy to implement and it's free. A non-free, quite expensive option is Guardian. I don't have any experience with that, but it is specifically or can do a better job of the auditing and will capture more information. Now, if you want to capture the running SQL, which is a request we get a lot, I want to know what this user did at this time, then you need to be using like a third-party tool that captures all the SQL that gets submitted to the database, or you can use SQL Trace. But each of these comes with some challenges, especially SQL Trace. Easy to implement, but you've got to be careful how you configure it because it uses a circular buffer. Those SQL statements will eventually disappear and you need to unload them. There's overhead with that. It's not really an ideal solution for auditing, but it may be something that can be done temporarily. If you're interested in the data changes that have been made, somebody updated a row, if that's a critical table, you may want to think about putting triggers on it so you can get update triggers. So when somebody changes a row, you put in, you save to another table what the person changed. Here's the row before it was updated, and here's the record after. For looking for changes to tables, alters, drop columns, that kind of thing, you may just want to unload your schemas every night and then do a diff between the two or something a bit more elaborate. It'll at least tell you that there were changes, and then you can look at the details to find out what changed. Now, you can use that together with the Informix auditing to maybe find out who changed it. So you can say, oh, okay, in the last 24 hours, somebody altered a table. Let's see who did that. And then you can go to the auditing, look for the ALTB event, and you go, oh, that was Jack again. All right, before I open up to questions, I want to tell you a little bit about our company. So we're XDB Systems, and we do a lot of remote DBA support, monitoring systems, almost exclusively Informix, and provide remote DBA consulting. We consult a lot on anything to do with Informix, and recently we've done a lot of migrations and a lot of upgrades. That's what we do. Okay, I'm going to open this up to questions. I haven't been keeping an eye on things, I'm afraid. So let's take a look.
Question or more of comments. Suggestion from Paul Watson to actually store the audit data in a time series
Yep,
table because it makes it easy to query and everything else and save space.
absolutely a great idea, especially the space part. Time series, got experience of that. It is the space savings and the performance can be very good. It's an ideal place to store it.
The other thing he adds in here, just so people on the replay hear it, is iWatch is the best I've found for SQL tracing and tracking, just so it's on the recording.
Very good. Yes, iWatch is certainly something I would recommend. I didn't want to name it specifically, but yes, that does a very good job of capturing SQL that has been submitted to the database with low impact to the database, low to none. Anything else, Tom?
Anyone else have any other questions? Okay, great. So Mike's got his email on there, so if you've got follow-up questions or anything else, or if somebody on the replay has questions, give Mike an email. All right.